So now we are going to discuss the classification of the crystalline solids. So basically crystalline solids are being classified into the following categories based on the type of the particles participate in the making of the crystalline solids. They are, starting one is molecular solids, second one is ionic solids, third one is metallic solids, and the last one is covalent, or these are also called as the network solids. So crystalline solids are basically being classified into four categories: molecular solids, ionic solids, metallic solids, covalent or network solids. Now let us discuss about the molecular solids first. These molecular solids are made up of the molecules. Molecules are the constituent particles in the molecular solids, because the name itself gives the molecular solids. So these solids are made up of with only molecules. And there was a question in the MSET and JEE also regarding the examples. They had given one example and asked what type of solid this particular molecule. That we shall discuss today. And molecules are not of the same category. They are having the different type of the molecules. So based on the nature of the molecule, these molecular solids again been classified into three categories. They are, first one, polar molecular solids, second one is non-polar molecular solids, third one is hydrogen bonded molecular solids. So three categories are there. So in these three categories, let us discuss about the polar molecular solids. Polar molecular solids, first of all, let us take an example, then you can understand what are these polar molecular solids. If you take HCl, a molecule, this we have already discussed in the states of matter. So in HCl, there is a covalent bond between the hydrogen and chlorine, and the electronegativity of the chlorine is more than the hydrogen. Hence, chlorine try to attract the shared pair of electrons more towards its side. As a result, chlorine gets partial negative charge, hydrogen gets the partial positive charge. When you take another hydrogen chloride, here also chlorine gets the partial negative charge, hydrogen gets the partial positive charge. Now here two poles are formed in the molecule, so it is called as a dipole molecule. Here also two poles are there. So poles are there, hence these are called the polar molecules. And there is a partial negative charge and a partial positive charge. So we can expect an attraction force between these two opposite charges. And these are not complete forces, complete charges, only partial forces. So since partial forces are there, and the attraction force that is existing or arises between the two dipoles called as dipole-dipole interactions. So it is a dipole-dipole interaction, or else we can call it as a dipole-dipole attraction. Okay. So these dipoles, you can take another HCl molecule this side also. So it goes on continuing like this. So it keep on continuing like this, so that again dipole-dipole interactions arises. So because of the existing of the dipole-dipole interactions among these molecules may exist either in the solid state or in the gaseous state or in the liquid state. Okay. So this type of the solids are called the polar molecular solids. So polar molecular solids are the solids where there is a polar covalent bond between the atoms, and there is a dipole-dipole interaction between the molecules. So between hydrogen atom and chlorine atom, covalent bond is there. But a hydrogen molecule, dipole-dipole attraction is there. So such type of the molecules are called the polar molecular solids. There are many examples you can take. NH3, solid NH3. Solid NH3 also comes under the category of the polar molecular solids, and solid SO2 also comes under the category of the polar molecular solids, where there are only dipole-dipole attraction forces are there. And we know that these dipole-dipole attraction forces are so weak force of attraction. Hence, it is easy to break these attraction forces just by supplying a little amount of heat. Hence, we say that these polar molecular solids are having the very low melting point values because of the weak attraction forces. At the same time, as I said, these attraction forces are so weak, it is not only easy to break, we can easily compress these molecular solids also. Hence, these are very soft in nature. Soft solids. Okay, because of the weak attraction force, these not only solids, actually they exist in the gaseous state, even in the liquid state also. And one more thing is, here no complete ions are there. Just like if you take the NaCl, there is Na plus and Cl minus, complete ions are there. But in the case of the HCl, or in the case of the polar molecular solids, there is a covalent bond, so that no ions will come out of the molecule. Since no ions are there, these molecules cannot conduct electricity. So these are insulators. These are insulators. So these are some of the characteristics of the polar molecular solids. I repeat about this one. Polar molecular solids are made up of with the polar molecules, where there is a covalent bond between the atoms and there is a dipole-dipole interaction between the molecules. Since weak attraction forces are there, they will have the low melting point values. They are soft solids and they are insulators, means they are bad conductors of current or electricity. Now come to the non-polar molecular solids. So in the case of the non-polar molecular solids, this is somewhat different from the polar molecular solids. Generally, non-polar molecular solids, you say we can take the carbon dioxide. If you take carbon dioxide example here, and it's a beautiful example. Carbon and oxygen. Oxygen is more electronegative than the carbon, so that oxygen try to withdraw the electrons towards its side. As a result, oxygen gets the partial negative charge. Carbon, since losing its electrons to the oxygen, it gets the partial positive charge. And between here also, oxygen gets the partial negative charge. Carbon gets the partial positive charge. So this we can take an example for the non-polar molecular solids, but people may ask the question, sir, here two poles are there, and here also two poles are there. Even though poles are there, we can call this one as a polar molecule, then it has to come under the category of the polar molecular solid. But why are we discussing in the non-polar molecular solid? Yeah, you see, if you see the dipole moment, the movement of the electrons are towards oxygen here, so that the movement of electrons are this side, and in this case of this particular bond, the movement of electrons are this side. So total movement, the movement of the electrons given by this bond actually cancelled by the other bond, so that dipole moment of this molecule is equals to 0. So it is once dipole moment is equals to 0, such type of the molecules are called the non-polar molecules. These are called the non-polar molecules. Like that, not only this particular one, you can take the argon, helium, and H2 molecule, I2 molecule. These are all non-polar molecules. Here argon and helium are the atoms. If you take the hydrogen, there is a covalent bond between the same atoms, so that there is no question which one is getting the partial negative charge and which one is getting the partial positive charge, because poles shall not be formed. Similarly, iodine also, there is a bond between the identical atoms, so that it is a non-polar molecular. So if any bond is there between the same atoms, such bond is not having any dipole moment, so such bond is called the non-polar bond, and that molecules are called the non-polar molecules. So iodine is the molecule that comes under the category of the non-polar molecular solid. So what type of forces actually exist in the non-polar molecular solids? See, I am taking the iodine, I2 as a molecule like this. Let us take I2 again molecule here, again I2 molecule here like this. Let us take several I2 molecules. So within the I2 molecule also, though the bond exists between the same atoms, for an instance, for a moment, imagine if the electrons suddenly flows one side. Actually it does not happen. Suddenly imagine if it flows one side. So one of the iodine gets the partial negative charge, the iodine that loses electrons gets the partial positive charge, and this separation of the charges is very limited time. So it is not the permanent dipole like in the case of the HCl. So it may come back immediately to their original position. So at any given moment, if there is formation of the charges or poles within the molecule, then this negative charge try to attract the electrons of the adjacent iodine molecule towards its side. This negative charge try to push the electrons of the adjacent iodine molecule towards the other side, because the electrons which are present here also carries the negative charge, and here negative charge is there. So there is a repulsion between the two negative charges, so that this negative charge pushes this iodine electrons the other side. So that electrons will come this side, and a partial positive charge shall be formed over here, and here also similar charges shall be formed. So these are called as the instantaneous dipoles. So instantaneous dipoles are the dipoles that forms for a moment and immediately they will disappear. So when they formed, immediately some attraction forces shall be arised. These attraction forces that are arising among the instantaneous dipoles are called as the London dispersion forces. London dispersion forces. Since these are not the permanent dipoles, so here the attractions are also not permanent. Once attractions are not permanent, it is easy to break them. So when you compare these two forces of attraction, dipole-dipole interactions are strong interactions in comparison to the London dispersion forces, because London dispersion forces are formed between the two non-permanent dipoles. So these are the weak forces of attraction. Hence we need very less amount of energy to break these attraction forces. Hence these are also having the low melting point values. But when you compare the melting point values of the polar molecular solids and non-polar molecular solids, the melting point value of the polar molecular solids is somewhat higher than the non-polar molecular solids. The reason here is strong attraction forces. And other properties are almost the same. Because of the weak attractions, these are the soft solids. They may exist in the gaseous state or they may exist in the liquid state also. And here also no ions are there, only molecules are there. So these are also insulators, means they cannot conduct the electricity, or they are bad conductors of electricity or heat. Now come to the point of hydrogen bonded molecular solids. So these hydrogen bonded molecular solids are formed between the hydrogen and or fluorine or oxygen or nitrogen of other atoms or same atoms. So if you take the H2 molecule, in H2 molecule oxygen is connected to the two hydrogen atoms, and here also let us take oxygen is connected to the two hydrogen atoms, and similar like this. We know that oxygen is a more electronegative atom, so that partial negative charge is formed, and here partial positive charge is formed on the hydrogens. So here also partial positive charge on each hydrogen, partial negative charge on the each oxygen. And here partial negative charge of the oxygen of the one molecule and partial positive charge of the hydrogen of the other molecule, they may attract to each other. So the bond that is developed between the partially negative charged high electronegative atom like fluorine, oxygen or nitrogen with hydrogen, only with hydrogen. So such type of the bonds are called the hydrogen bond. And hydrogen bond is a bit stronger in comparison to the this London dispersion forces and dipole-dipole interactions. And one question generally arises among the students: sir, here also hydrogen is participated, and here also hydrogen is participated, and here also hydrogen carries partial positive charge, here also hydrogen with a partial positive charge, and some extra atom, electronegative atom with a partial negative charge, and here also some electronegative with a partial negative charge. Then why are we calling this particular bond as a polar dipole-dipole interaction? Why are we calling this one as a hydrogen bond? See, we call hydrogen bond as it is a type of dipole-dipole interaction. There are two types of dipole-dipole interaction. The dipole-dipole interaction that is formed between the hydrogen with either fluorine, nitrogen, oxygen is separately called as the hydrogen bond. And dipole-dipole interaction that is formed among other dipoles is simply called as the dipole-dipole attraction forces. So whenever hydrogen is attracted towards higher electronegative elements like fluorine, nitrogen, oxygen, the dipole-dipole interaction is so strong in comparison to the dipole-dipoles that are formed between the other molecules. Hence, it is separately called as the hydrogen bond. It is so strong bond. Since it is so strong bond, it needs a bit more heat energy to be broken. Hence, it is having high melting point value in comparison to the other two, but as a whole, means in comparison to other solids, means ionic solids, covalent solids, the melting point is low in comparison to other. But here non-polar molecular solids, it is very low. So melting point values. Next, and these are hard. These are not soft because hydrogen bond is so strong bond, no? That's why they are hard. That is the reason why ice completely exists in the solid state. Okay. Next one, even liquid ammonia also, it shows hydrogen bond. Here I have taken the solid ammonia. Solid ammonia, the attractions present between the ammonia molecules in solid state is a polar means polar dipole-dipole interactions. But in this case of liquid ammonia, the attractions are called as the hydrogen bond. And these molecules are a bit hard in comparison to the other two. And it is also insulator, means it is a bad conductor of both electricity and heat. Now, question arises among these molecular solids, because these are the three of the molecular solids: polar molecular solids, non-polar molecular solids, and hydrogen bonded molecular solids. All these three come to the category of the molecular solids. Among these three, which are having the high melting point values, which are having the low melting point values. So let us see here melting point value orders. So melting point value is more for the hydrogen bonded molecular solids. Next one is polar molecular solids. This is important. Next one is non-polar molecular solids. So this is the order one has to understand. And second thing is, I said no, one question was asked in the previous examination, that is about the iodine. They asked iodine belongs to which type of solid? They had given polar molecular solid, non-polar molecular solid, hydrogen bonded molecular solid, and a covalent solid, because covalent bond is there, no? So that's why they had even given the covalent solid. But it belongs to the non-polar molecular solid. Now, let's try to discuss the ionic solids. So, ionic solids here. Ionic solids are formed basically due to the presence of ions. We know that ions are of two types, they are positive ions and negative ions. Let us take an example over here. Best example, many examples are, I am taking only one example, that is NaCl, which is a common example. So, in this Na plus Cl minus ions are present. So, here Na plus ion attracts the Cl minus ion around it. Similarly, Cl minus ion also attracts the Na plus ion around it. So, the attraction is developed between the two ions, and these attraction forces are so strong. See here, if you take the Na plus ion and the Cl minus ion, these are not the partial charges. Whatever the positive charge, negative charge we are taking, those are complete charges. So, due to the presence of complete charges, they can be attracted very strongly to each other. That's why this attraction force is so strong. And this attraction force is developed between the two charges. Charges usually we call it electrostatic. So, we call this one as a electrostatic charge. So, this is called electrostatic charge, or usually we call it as a ionic charge or ionic bond, because the bond means basically attraction force. The attraction force that is found between the two ions is called the ionic bond, and that ionic bond is due to the developing of the electric charges on the ions. And these are very strongly attracted to each other. So, this ionic bond is so strong bond and it needs high heat energy to be broken. So that's why they will have the high melting point values, and these are very strong, and these are hard and brittle. Hard and brittle. What does it mean by hard and brittle? See, when you try to press a particular ionic solid with hand, it is difficult to compress that, or it is difficult to break that particular ionic solid. But at the same time, when you try to drop that ionic solid on the floor, the moment when it drops, it breaks down into the small pieces immediately. So that nature is called the brittle nature. Though they are hard to hand, but they are not hard to the surface, floor. So they can easily be broken into the small pieces. So that nature is called the brittle nature. Okay. So these are very hard and brittle in nature. And one more important thing is regarding their conducting nature. Conducting nature means in solid state. This is important. In solid state. In solid state, if you take any ionic solid like NaCl, for example, Na plus and Cl minus ions are there. In solid state, these ions are not free enough to move around. They cannot move because they are fixed to their positions. Because here again Cl minus ion will be there, here again Na plus ion will be there, this side Na plus ion will be there, this side Na plus ion, again here Cl minus ion, here Cl minus ion. So if you take a particular Na plus ion, it is surrounded with Na plus, if you take Na plus, it is surrounded with the Cl minus ions. Similarly, if you take Cl minus ion, it is surrounded with the Na plus ions. So no ion is free to move around. So they are fixed to their positions. Hence they cannot carry out any electricity when they are in the solid state. But in liquid state or molten state means when you try to keep this particular solid in the liquid state or in the solution, then this NaCl dissociates into Na plus and Cl minus ions. The ions are free in the liquid state so that they can easily carry the electricity from one end to the another end. Hence they are good conductors of electricity only in the liquid state, and they are bad conductors of electricity in the solid state. This is about the ionic solids. Now let's try to take the metallic solids. Hope you will understand what I am going to discuss about the metallic solids, because here we are going to discuss about the metallic bond also. So metallic solids. So in metallic solids, basically these solids are made up of with the metal elements. Elements of metal or simply metal elements. What are the metal elements? You can take any metal elements like silver, gold, magnesium, zinc, copper, any of these, iron, best examples. So these are all metals. So the metallic solids are made up of with the metal atoms, not with the normal atoms like non-polar solids. And what other characteristics we have to understand from the metallic solids? Before that, we should understand what is metallic bond. So here I am going to discuss about the metallic bond. Please try to pay attention. We know that if you take any metal, metals are highly electropositive in nature. They are always ready to lose some electrons. So if you take metal, if it loses n number of electrons, it will get the n positive charges. So if it loses 1 electron, here it will get the 1 positive charge. If it loses 2 electrons, it will get the 2 positive charges on it. And all these metals, after losing electrons, they form the positive charged ions. These positive charged ions are called as the kernels. Kernals, kernels. So basically metal, if you take, this metal is made up of with not only purely metal atoms, actually it is made up of with the combination of the positive metal ions and the electrons released by that particular metal ion during its formation. Now see here, I am going to take this Mn plus ion as a positive ion, here also positive ion, here also positive ion. So metal is basically made up of the metal kernels, metal ions like this. Metal ions are formed. These are all kernels. Then where these are located? Electrons. These electrons are placed in between the metal ions, kernels, like this. Like this. Okay. Now, generally we know that metals are so stable and they are so strong. The reason is each metal ion is surrounded with the electrons and each electron is surrounded with the metal ions. So they will have the so many number of the strong force of attraction, and because of the strong force of attraction, these metallic solids are so strong in nature. Strong in the sense immediately they are very hard also. And second thing is, these electrons are not confined only to particular metal ion. Means actually these electrons are free electrons. They can move from one particular position to the another particular position. Means one particular end to the another particular end. So they can easily flow. Hence these electrons are called the sea of electrons, or people call it the electron sea. Electron sea means if you imagine the complete metal is made up of with the only electrons, and these metal ions are appeared like they are immersed in the sea of electrons. Okay, because of these metal ions and electrons, there is so strong attractive forces, and these are very strong in nature. And other thing is, these electrons can flow from one particular position to the other particular position. That's why they can easily carry the electricity from one end to the another end. So these are very good conductors of electricity. Very good conductors of electricity. So they can conduct the electricity from one end to the another, and even good conductors of heat also. And next one is, sir, there are so many type of the metals. Some metals are soft in nature, some metals are hard in nature. What is the reason? The reason is very easy. The strength of the metal depends on the electrons given by the metal during its metal ion during its formation. See, if you take sodium, sodium gives only one electron and forms Na plus M. And if you take the magnesium, magnesium forms Mg plus 2 by losing 2 electrons. When you take aluminum, aluminum forms Al plus 3 by losing 3 electrons. And if you take iron, iron can easily form Fe plus 6 by losing 6 electrons. Like that. Means more the number of electrons available, stronger will be the metallic bond formed over here, and the strong will be the metal formed. That is the reason why S block metals are very soft in nature. Means starting first A group and second A group metals, they are very soft in nature because they release only less number of electrons. They contribute only less number of electrons towards the metallic bond formation. And remaining D block metals are so strong because iron, zinc, all these are there. They are very strong. Reason is they release more number of electrons towards the metallic bond formation. What is metallic bond? The bond that is formed between the free electrons and the metal ions is called the metallic bond. More the number of free electrons available, so strong the bond will be formed. So strong the metal also. This is about the metallic solids and metallic bond. And the last one is, fourth one, covalent solids or network solids. Covalent solids or network solids. So now let us see here what does it mean by covalent solids and how does these are formed. These are basically formed due to the presence of only atoms. The constant particles in covalent solids are atoms. Best examples are diamond and graphite. We can take both, even silicon carbide also we can take, SiC. All these come under the category of the covalent or network solids. So basically covalent or network solids are the solids where atoms will be there. These atoms are connected to each and every other atoms through covalent bond like this. and again this is connected to the other elements through covalent bond. In this way they form a network, hence these are called as the network solids. If you take the diamond, this is the structure of the diamond, where diamond is having the tetrahedral shape. One carbon atom is connected to the 4 other carbon atoms like this. So it keep on continuing like this. And if you take the graphite, graphite is having the hexagonal structure, planar shape actually. So this is one plane, and next we can write one more plane in the case of the graphite like this. So graphite forms a layer structure where one layer is connected to the other layer through van der Waals forces of attraction. Because of this force of attraction, one layer can slide over the other layer. And here in the case of the diamond, these are completely connected to each other just like a network, so they cannot move. So that a diamond is so hard and graphite is soft. And except graphite, because graphite we cannot completely discuss in the covalent solids, it is an exceptional case. Except graphite, remaining all covalent solids are having the network like covalent bonds, so that's why they are very hard and they possess very high melting point values, and they are bad conductors of electricity. They completely insulate, they cannot conduct any electricity because of the absence of free electrons. But graphite is somewhat different from these natures. Graphite is soft in nature because of the layer structure. It is having the low melting point value, and it is a good conductor of electricity due to the presence of free electrons. So this is only exceptional case in the case of the covalent solids. So I repeat this all the solids in a chart. So first one is molecular solids, second one is ionic solids, next one is metallic solids, last one is covalent solids. Okay. Now in molecular solids, molecules are the constituent particles. Ionic solids, ions are the constituent particles. In metallic solids, metal atoms are the constituent particles, metal atoms or kernels. And in covalent solids, only normal atoms are the constituent particles. And in the molecular solids, what type of attraction forces are present? They may be dipole-dipole forces, or they may be London dispersion forces, which are also called as the van der Waals forces, or there may be hydrogen bond attraction forces. Ionic solids, ionic bond is present, or it is also called as the electrostatic bond. And in the metallic solids, a metallic bond is present. And in the covalent solids, a covalent bond is present among the atoms. And next, molecular solids are soft in nature, ionic solids are hard in nature, metals are also hard in nature, and covalent solids also hard in nature. Molecular solids are bad conductors of electricity, ionic solids are bad conductors of electricity in solid state, but good conductors of electricity in liquid state. And here metallic solids are always very good conductors of electricity. And covalent solids, bad conductors of electricity. Only good conductor of electricity is graphite. The graphite is the exceptional case, remaining all bad conductors of electricity. And when it comes to their melting point values, these are having very low melting point value, that is molecular solids, whereas ionic solids are having high melting point value. Metallic solids are also having high melting point value. Covalent solids are having very high melting point values. So this is about the type of crystalline solids. Hope you understand. If you want, you can repeat this video for your understanding purpose. Thank you one and all for joining today's session.